最初のセッションは Be a Happier Developer with Git と題し、アトラシアンディベロッパーアドボケートティム・ピーターセン、同じくアトラシアンビットバケットディベロッパーアービン・シャーブラより講演いたします。
Thank you very much. It's a big honor for me to come from San Francisco to come and speak a little bit about Git and how we use Git at Atlassian. So, as was already mentioned, there's two of us here today. My name's Tim Pettersen, and I'm a developer advocate at Atlassian, which means I do a lot of traveling and speaking and writing about Git and developer workflows. With me today, I have my good friend and colleague Abhin, who's a Bitbucket developer. Bitbucket, for those of you who do not know, is a Git hosting service where you can host Git repositories for free if you want to try it out. So, as was already mentioned, there's sort of two sections to this first part of the presentation, where Abhin will be talking about how Git makes you a happier developer, and I'll be talking a bit about how Git and certain workflows that you can implement with Git make you a more productive team. Before I go any further, I do just want to say thank you again very much to our partner and Atlassian expert, Ricksoft, who sponsored tonight and paid for the beer and food that we'll be consuming afterwards. So thank you very much, Ricksoft. Now, as Stuart mentioned before, Atlassian is a software development company. Most of our products are built to help us solve problems with software development. We started out with an issue tracker, Jira, and then we built a collection of tools that help developers work by themselves, and also with software development teams. So it's really kind of the collaborative aspect of software development that we're trying to nail with our products. So Abhin is a Bitbucket developer. I do have some Git credentials as well. This is a commit log, so a list of commits that have occurred in the Atlassian Stash project. And what you'll see is up the very top are some commits from myself. So Atlassian Stash actually started as a project during a hackathon. So that's a programming competition that we had at Atlassian. During this competition, I was working with just one other developer, a gentleman named Michael Heemskirk, who is now residing in Holland, but still remains the Atlassian Stash architect. Now, when it was just Michael and myself working, we were very productive, because every time one of us had an idea for what we wanted to build in Stash, we'd just tap the other person on the shoulder and say, hey, I have this great idea. And then we'd build it. There wasn't a lot of time being spent in meetings, doing planning, onboarding developers, and collaborating with a team, because we were sitting right next to each other. However, when we grew the team, when we decided that Stash would be a product we want to sell outside of the company, it got a little bit more complicated. We started adding QA engineers, team leads, technical writers, designers, all sorts of other people that we had to collaborate with. And collaborating with these people, while it was an enjoyable experience, does cost a little bit of time. And it meant that each individual developer was being less productive. Plus, when we decided in early 2012 that we wanted to start selling Stash to customers, we discovered there was another class of people watching our development, people with ties. So these people with ties weren't very technical. They weren't necessarily interested in the code that we were writing. They were more interested in the product that we were building. And we needed a way to communicate with them as well. So we realized that software development isn't just a technical challenge. It's not just about writing code. It's also a social challenge where you have to collaborate effectively with people who may not be developers. And that's that's the problem that we're trying to solve with the Atlassian toolset. We try to build tools that make it easier to develop software in a team. And that, hopefully, if you use Atlassian tools, you'll be able to ship software faster and smarter to your own customers. And that's why we're here today, because we want to talk about another piece of software that's very important to us at Atlassian, Git. Now, Git isn't something that's built by Atlassian. We don't have any developers who contribute to the Git project, but it has fundamentally changed the way that we ship software to our customers. Now, Git is the version control system that is growing in popularity all over the world. More and more teams are switching from older version control systems, like Subversion, to Git. Developers love it because it's fast. You can use it offline. So both Abhin and I were doing some development on the plane over from San Francisco. It's distributed, so it has all of these features that make it easier to use in a team context. And best of all, it was built by Linus Torvalds, the gentleman who gave us the Linux operating system. Now, Abhin will be up shortly to talk more about how Git makes you a happier developer. So I'll get him up in just 1 second. But first, I do just want to show you some of the teams that are already using Git and Stash. So there's sort of a myth with Git usage where people seem to think that the teams that are using Git are open source projects or very small software startups. There's also a myth that people using Git are using it only in the cloud on services like Bitbucket or GitHub. But what we've seen is that this isn't the case. So just like Stuart showed before, there's a large number of Atlassian customers. These are all teams who are using Git and Stash on servers that are sitting on their own behind their own firewalls. And these are not small development shops. These are very large companies with very large enterprise-grade software teams using Git to ship software faster and smarter. If you're not already on Git, we've actually got a site that will help you make the switch from Subversion to Git, or from CVS, or from the Force, or whatever version control system you're currently on. It's at atlassian.com/Git. So what we've done is we've taken all of our experience with working with Git and then built a website with all of that reference documentation. But at the end of the day, Git is just a tool. And for those of you who have migrated already, you'll know that switching to Git has kind of a non-zero cost. There is a bit of a learning curve. So what this presentation today is designed to do is to hopefully inspire you to switch to Git and also show you some techniques for using Git to get the most out of your software development process. And with that, I'm going to stand aside for a moment, and Abhin is going to come up and talk a little bit more about how Git makes you a happier developer. Thank you very much.
Can everybody hear me at the back? Welcome to this part of the presentation. This part of the presentation will deal with why Git will make you, a developer, happier. If you've already used Git, you already know how awesome it is. If you have not used Git, you have a lot to look forward to. As a show of hands, how many of you have used Git for longer than 1 year? Okay, so I would say that's about 30%. How many of you are planning to migrate to Git within the next year? Okay, that's a smaller number, maybe 15%. I hope to increase that number by the end of the presentation. A version control system is supposed to be a log of all events that have happened in your code base, all the changes that have been made. Every version control system is. You can go back in time and see who introduced what feature, and that is normal. But Git is one step better. You can go back in time and not just view your repository, you can go back in time and change an action that was taken in the past and watch the change propagate to the future. You can rewrite your history. Git is more like a time machine than a version control system. But I'm getting ahead of myself. Let's start at the beginning. There are 4 reasons why Git is really awesome. Number 1, speed. Git is fast, very fast. For those of you who have used it, you know exactly what I'm talking about. And for those of you who have not, you better wear your seatbelts. Second reason, Git gives you the freedom to multitask. You can work on multiple features simultaneously. You don't even have to commit your code. You can switch back and forth between features if you want to, even without committing. And it has safety. It's very hard to lose data with Git, and we'll go over that soon. Number 3, like every version control system, you can go back and explore the history of your project. You can understand who introduced a feature, why, how a feature came to be, etc. But unlike other version control systems, Git offers some really, really nice tools to explore your project's history. And this is the advanced part of the talk, and this is the funnest part of the talk. The part where you're allowed to rewrite the history of your project. During the presentation, I will try keeping everything very close to the ground, but towards the end, I will touch some advanced stuff. If there are any questions, I propose waiting till the end. There will be time for questions. First off, speed. Git is very fast. I will say this sentence many times during this presentation. Git is very fast. It's so fast, it will change the way you develop. Git does not get in your way when you're writing code. There are other version control systems that are slower, like SVN, and they have to reach out to a central server for almost every operation you do. That slows you down, that slows developers down, that gets in your way. Git would not. Git is a distributed version control system. We'll go over that in a minute as well. The first reason why Git is really fast is because everything is local. Your computer has the entire history of your project available locally. This means that for every operation, your computer can perform every operation locally, except for pushes and pulls. You do have to share your work with other people. Except for those, everything happens locally. And this has amazing speed advantages. As I've spoken before, SVN suffers from a design flaw. Almost every operation requires SVN subversion to go out to a centralized server. That server may be on the other side of the globe, or it could be bogged down with other people requesting any things. And this makes Git really, really fast. The second trick up Git's sleeve is that it's written by some of the best engineers on the planet. It is written by the same people who wrote Linux, and the same people who wrote the Linux file system, and it's written almost entirely in C. These people know almost every trick in the book to speed a program up. In fact, the first version of Git was written by Linus Torvalds himself, and then he handed it off to other developers who are like him, have the same ethos, and are really good at file system. As a developer on Bitbucket, I can attest to that. Sometimes we've had to re-implement some of Git's commands. We've tried matching the efficiency of Git's native implementations, but we've never managed to pull it off. And we have some of the smartest engineers out there, but we cannot match the skill with which native Git has been written. It is very well written. Here's my proof. Except for cloning, Git is faster for every single command. Git is slower for cloning because it's getting the entire history of your project. SVN only has to get the latest version. Git has to get the entire history. But you clone once. Once you've cloned, every operation is dramatically faster than Subversion. What if you have a big repo? Well, if your project is big, Linux is probably bigger. Linux was the project for which Git was written. And Linux has more lines of code than your project, almost certainly. This is the newest release of the Linux kernel. It has 12,000 non-merge commits. We will talk about what those are, but a non-merge commit is a commit which contains real work. Lots of lines of code and way too many contributors, and it works just fine. Even on the Linux kernel, most operations return in seconds. The second reason why Git is awesome is because it gives you the freedom to multitask. Git allows you to work on multiple features simultaneously, and you can switch back and forth with ease. At the same time, it is very difficult to lose your work. Git was designed with these workflows in mind. Almost no developer works on one thing without having to switch back and forth between other features. And this reliable and efficient context switching is because of two popular features. Number one, feature branching. A branch is a separate, isolated context in your version control system within which you can do some work without affecting your main code. Out of curiosity, how many people have used branches? So that was about 20–30%. But a branch, as I said before, is how you work without affecting your main line of code. In Git, you're supposed, it is suggested that you create a new branch for every single feature you work on. It could be a bug fix, it could be a typo, it could be a change in documentation, it could be a real feature. You create a new branch. And Git will safely restore the contents of each branch as you switch back and forth. Most version control systems implement branching. SVN implements branching too. But not all implementations are equal. SVN implements branching in a much less sophisticated way, and that causes merging to become difficult. What is merging? Well, when you create a new branch to work on a new feature, after you think you're ready to take those changes into your main line of code, you do a merge. A merge is the act of pulling changes from a feature branch into your main branch, or your trunk if you're from SVN. In Git, branches are local, just like everything else. That makes branching fast, and that's a good thing. At the same time, in Git, merging is relatively easy. It is more sophisticated. We will talk about that very soon. But if merging is difficult in your version control system, developers tend not to use it. We found that to be the case with SVN. If merging is difficult, then developers start coding on the main line of code, also known as trunk. If developers code on trunk, then for the most part of your product's lifetime, your trunk has unfinished changes. That means you cannot release whatever you want, because for the most part, you have unfinished features in your trunk. That means to release, your company will probably institute a code freeze. A code freeze is when all developers are asked not to work on any new features and finish working on all the unfinished features in the trunk, or to make bug fixes. That means for developers not involved in this process, they're wasting time. They can't do much work because they can't work on new features, and that's bad. Branching is what allows this to not happen. In Git, you branch for everything. As I said, the smallest thing, you create a new branch. This is a visualization of all branches in Git's own Git repository. That's a lot of branches. That's a lot of things being worked on in parallel. That is good. That is what productivity looks like. And that's what we should aim for. As I said before, branches are local, which means unless you're ready to share your work with other developers, nobody can see your work. Reinforces the concept of isolation. So let's go through a scenario. You're about to start working on a new feature. You go to your master branch, the main line of your code, and you use this statement to create a new branch. Then you start working. You make a commit, you make another commit. After some time, you feel like you're ready to share your work with other people in your team. Maybe you want some feedback from senior developers. When you're ready to get feedback from senior developers, you push. This will push your local changes to your server, so other developers can see your work. Maybe they can use it. This does not mean you're ready to ship your code. This does not mean you're ready to merge your code into your main line of code, into your master branch. This means you want to share your work with other people. When you feel like you've completed your feature, you can merge. We'll talk about merging later. The second way you can work on multiple features at the same time is using something called stash. This is not to be confused with Atlassian's stash product. This is a command in Git itself. It It's a way of temporarily storing unfinished work in a separate space. So let's explain this using a story. You're working on a feature branch, you've made some commits, you're halfway done a unit of work, but you're not ready to commit. And your boss comes in. Something's wrong in production, and your boss needs you to deploy a fix right now. Well, you can use git stash to stash away your unfinished work, and now you'll have a clean working directory. Then you can switch to the master branch. You can work on that bug fix, merge, push, deploy. Go back to your old feature branch, use git stash to restore the state you were in, and continue working. So git stash is a really nice feature offered by Git. You can do the same thing in SVN, by the way. In SVN, what you will have to do is create a patch. You create a patch of your unfinished work and save it in a temporary location yourself. Maybe you can email it to yourself, maybe store it on Dropbox. Then you do the bug fix, deploy it, then you try applying that patch back to your branch. But this is SVN. You're working on trunk. Now you're trying to apply a patch to a different revision than the one it was made in. You'll probably run into problems because SVN has a badly engineered patch format. You'll discover that the binary patch format for SVN is also not that good. And you'll probably have corrupt binary files. Git's better at that. I talked about how difficult it is to lose work in Git. This section is about that. Losing work is very hard. Very, very hard in Git. Let's go through some scenarios. Your Git server crashes. Big deal? No, not really. In SVN, this is bad. Someone will have to reconstruct the SVN server, and then they'll restore it from an old backup. And you will lose all the work since the last backup. With Git, this is not a big deal. Every single developer has a copy of the entire history of your project. Every single developer has a backup. You can restore it in minutes. And even while your server is down, you can continue developing because you don't need access to the internet. Even if you wanted to share, Git comes with a server built in. You can share work between each other. You can do peer-to-peer development. In an interview, Linus Torvalds, the guy who created Git, said that he does not keep backups of Linux's Git repository because every single developer is a backup. It is possibly the most backed up project in the world. Not on purpose. It's just because it uses Git. But that was a serious scenario. Let's talk about some easy scenarios, some pedestrian scenarios. You deleted a file. Is that a big deal? No. You run git, check out, name of that file, and you're back to where you started. Not that hard. If you wanted to recover the state of your project at a certain version, you use that command. Every commit has a unique signature. That's called the SHA. You can also check out your project by branch name or tag name. It's not that big a deal. Maybe you don't want to check out what your project Maybe you don't want to check out your project at a certain version. Maybe you just want to see what a file looked like. Git show will show you your file for any given revision. And that's the path. Maybe someone deleted a method and you can't find it. It happens all the time. You know someone deleted a method because you know a method exists and you can't find it. You can use the git log to find any method name by just putting it here. Really simple. Let's say you delete an entire branch. Is that a big deal? No. How many of you have accidentally deleted the wrong directory at some point in time on your computer? No? You guys are good. Okay, more hands. The translation went through. When you accidentally delete the wrong folder, you will probably have discovered some undelete utilities. How these undelete utilities work is by looking at your file system to see if a file exists that is not linked in the file system. Why? Because when you delete a file, most operating systems don't actually delete that file. They just unlink it. Git does something similar. Every branch is just a pointer to a sequence of commits. When you delete a branch, those commits are not deleted. The pointer is deleted. Those commits will stay for about 30 days. And you can change that number to whatever you want. And you can look at the reflog. Git keeps a log of all the branches in your system. Any changes to any branch. You can use that to figure out the commit that your branch pointed at and recover it. If you want to learn more about the safety features in Git, I encourage you to check this out. Number 3, the third reason why Git is awesome. It has some really nice utilities to understand the history of your project, to understand where a feature came from, and who created it and why. Let's ask ourselves a really hard question. What did Mike do last week that changed this method? How do you find that out? You can use git log, which has an author flag, an after flag, and a before flag. And you can add it to the name of your method. And you can easily run through the history of your project. Git log has many, many amazing flags. You can use this to list where a file was deleted, which commit a file was deleted in. You can use that to list all the deleted files. They're really interesting if you read through the explanation of how those work, but we'll probably have to skip over those. Talk to me afterwards if you want to understand how they work. You can grep through the history of your entire project. Git offers a tool for that. You can list all the branches that have been merged, or all the branches that have not been merged. Git has tools for that. In general, Git has a lot of awesome tools. Just try typing git help log. You'll see all the features, and there are a lot of features. This is the advanced part of the talk, about going back in time and changing the history of your very project. It may seem that going back in time and changing the history of your project is an academic exercise, but there are some real workflows that can be implemented with this feature. There are some real world use cases that we will go through. Before I talk about rewriting your history, I'll step back and talk about merging for a little while. What is a merge? When you work on a master branch and you branch away to work on your feature, and you like what you've done so far, you will want to include that into the master branch. This is called a merge. It will create a new commit called a merge commit that is the result of union of your feature branch and your master branch. For any version control system, merging is very important. We discussed that branching is good for productivity, but every branch needs to be merged. SVN claims that branching is one of its strengths. It claims that branching is simple. But if you can merge those branches, then that feature is kind of useless. With Git, the merging of branches is very, very simple. And it's better because of 3 reasons. 1, it's fast because it's local. Second, Git knows the entire history of your project. For a merge, it will look at the tip of your feature branch, the tip of your master, and the common ancestor, and that's the 3 pieces of information it needs to calculate your merge. Why is that important? Because if you have a very, very old feature branch, it'll still take very little work for Git to calculate the merge. In SVN will have to go through all commits in your feature branch. It's slow and complicated. Number 3, Git has pluggable merge strategies. Merging strategies are the algorithms used by Git to calculate the merge. And Git allows these algorithms to be plugged, so you can make use of the newest algorithms out there. Merging becomes a non-event. That is not a baby crying out of pain. That is a baby bored out of its mind. Because merging is really a non-event. With that covered, I can now talk about rewriting your history. Rebase is the command that allows you to rewrite your history. I'll discuss rebase using a story, a scenario. Let's say you've been working on your feature branch for a while. But while you've been working, other people have been making changes too on the master branch. You're right here. You discover that there's a bug in master, and you need that bug fixed. What do? You merge master into the feature branch. You can do these merges as many times as you want. But after a while, your feature branch will have your commits and some random merge commits thrown in. Which means, if you look at your feature branch, you will see a lot of changes that you had nothing to do with. How do you solve that problem? Well, you can create a patch for this commit, and a patch for that commit, and a patch for all the commits in your feature branch, and store them in a directory. Then you can go to the tip of the master branch, delete this old branch, make a new branch with the same name as your old branch, and apply the patches in the right order by hand. When you do that, you have the changes from your master branch without merging master into feature. Git rebase is a tool that will do this automatically. That is all there is to it. In some companies, they prefer rebase over merging. Let's say you have a feature branch and you want to merge it into your master branch. In some companies, they recommend that you rebase the feature branch on top of the master branch. Apply the patch, apply the patch. You can do this with one command, the git rebase. But that was an introduction to rebase. Rebase is a lot more powerful than that. There is an interactive mode where Git rebase will offer you a lot more features. You can squash commits together, you can split commits up, you can fix them up, whatever. Very powerful. I recommend that you check it out sometime. Just go git help rebase. I have to warn you though, in that illustration earlier, it seemed that you magically moved those commits over. That is not what's happening. You're making new commits. This is an entirely new branch. If you push a branch, then rebase it locally, then push again, you will be trying to push a completely different branch that happens to have the same name. Git servers do not like that. So if other people have shared your work, do not rebase. So, to recap, 4 reasons why you should like Git, 4 reasons why you should love Git. It's really, really fast. I cannot emphasize that enough. It gives you the freedom to work on multiple things simultaneously with safety belts on. It lets you understand the history of your project and gives you a lot of cool utilities. And it lets you rewrite history. It's got magical powers. It's a time machine. If you find those commands really complicated and you prefer a GUI, you can always try our free product called Atlassian Source Tree. Give it a shot. And hopefully, Git will then make you a much happier developer. Thank you.
ご清聴いただきありがとうございました。それでは本セッションについての質疑応答に入りたいと思います。ご質問が日本語で構いませんので、ご質問のある方は挙手をお願いいたします。そちらの、すいません、申し訳ございません。まだセッションの続きがございますので、質疑応答はそちらが終わり次第開始したいと思います。大変申し訳ございませんでした。
まだ終わってないですね。続きありますか？
Thank you very much. Oh, that's okay. Thank you. Well, there will be some time for questions at the end. So that was Abhin on why Git makes you a happier developer. Now I'm going to be talking a little bit about how Git can make you a more productive team of developers. So there's 3 major points that I want to talk about in terms of Git in a team context. The first is how to build an efficient and elegant workflow on top of Git. The second is how switching to Git magically improves the quality of your code. And the third is I want to talk about how Git works with the development tools you're already hopefully using. First of all, how to build an efficient workflow with Git. So a development workflow should tell you different things about how to develop software. If there's a bug that you find before you've released a particular version, then you need to know how to fix that bug before you release it. If you've got more than one developer working on your project, you might need to know whether a particular feature is finished before you release that version as well. Also, in the worst case, where you ship a bug to your customers and they call you up and say, this needs to be fixed, you need to know how to fix that bug as quickly as possible and release it to them. And if you're using code review, you need to know whether other developers in your team have finished reviewing your code and whether it's ready to ship. Now, I'd love to be able to tell you, hey, this is the perfect Git workflow for your team. But unfortunately, we don't know what the perfect Git workflow is. Different teams have different needs when it comes to workflow. Different cultures require different factors as well. So if you're working for a website that's in Silicon Valley that sells designer pet food to people with cats, it doesn't matter too much if you ship a bug because you can fix it before the user refreshes the page. But if you work in the biomedical field, building pacemakers, or if you work for a space agency building rockets, then there's a very high cost of failure for the bugs that you ship. So you need to have a more stringent workflow. Similarly, different products have different workflow requirements. If you're working on a product that's a SaaS or software as a service application that's running on a server that you control, then you can very quickly deploy new versions of your software. But if you're working for a mobile application, or if you're working on something that gets installed on laptops or servers, then deploying the latest version of your software to all of those things isn't a possibility. You have to wait for users to upgrade. And this means you have to have a different workflow because you have to maintain separate stable versions of your product. Similarly, different teams and team structures have different workflow requirements. If, like with Stash, you just had 2 developers working on the product, then you don't need a very formal workflow because you can just talk to the person next to you. But if later down the line you grow that product team out, like Stash has 25 developers working on it now, you have to have a more structured workflow to make sure that everyone can continue being productive. So it's the combination of all of these factors that leads to the workflow you'll need to choose for your software projects. Now, I can't show you a perfect workflow for you, but I can show you some of the workflows we use at Atlassian and describe the basic elements of every good Git workflow. And hopefully you'll be able to use these to construct a workflow that works for you. So at the core of every software development workflow, there are 2 basic things. There's the issues, so these are the features, or the bug fixes, or the gradual improvements that you're making to your software. Then there's the code. So these are the deltas, the patches, the actual lines of code that you're changing that implement these issues. Now, if you're using Jira for issue tracking, you'll have a set of issues that have issue keys. And it's a common pattern to annotate your commits with the issues that those commits are addressing. Now, if you're using a non-branching workflow, so if you're using Subversion and just committing to trunk, then you might get this problem where different issues are fixed at different times. And this, like Abhin mentioned before, makes releasing quite difficult. Because you never know, well, it can be difficult to know whether all of the features that are committed are actually ready to be released, or whether the developers want to commit more code. So this usually means implementing a code freeze, where everybody stops work until we determine what's ready, whether we're ready to ship. So every software team at Atlassian, we have 500 developers and about between 70 and 80 teams. Every team at Atlassian follows feature branching. Basically, this means we create a new branch for every issue that we're working on. So this means that we get all of the code for that feature ready to ship. We make sure all of the continuous integration tests are passing. And we make sure that it's code reviewed before we merge it back into master and release it to our customers. And this gives us two very important features. The first is that we're developing in complete isolation. So this means that if another developer breaks a test, we don't care, because we're working in isolation on our branch. And this has a lovely corollary in that it also means that everything that is merged into master is ready to ship to our customers. So instead of having to call a code freeze, we can just look at the tip of master, which is the latest commit, and see all of the branches that have been merged in. And we know that all of these features are feature complete and ready to ship. So we use a naming convention for our branches. Basically, we start with the type of issue that we're fixing on the branch. So this might be feature for a new feature, or bug fix for a bug that we've found before we've shipped that version of the software, or hot fix when an unanticipated bug is released and we have to fix it for our customers. We follow the type with the issue key that it's relating to. So we can use this to track from the issue to the code. And we can also use it to track from the code back to the issue. So we can see the full context of the problem that we're solving. Plus, we also have a short description of what the branch is doing. This is so that if we're running the git log command or the git branch command from our terminal, we can tell exactly what that branch is without having to go and look up the issue key. So this system works very well for us, but there is one slight problem. You have to switch between Jira and the command line and stash to determine what to name your branch. Plus, developers sometimes make mistakes. And if you accidentally mistype that issue key, then all of that tracking disappears, and you can't get that context of what the branch is addressing from looking at the branch name. So we've implemented a feature that allows you to create branches on the server. In Jira 6.2, we ship the ability to click this create branch link directly from your Jira Agile wallboard. Now this is a bit counterintuitive if you're used to using Git. Typically, you create branches on the command line or from your local machine. But creating it on the server has two very important advantages. The first is that the branch name is pre-populated for you based on the issue key. So as a developer, you can't accidentally type the wrong key. So that solves the typo problem. But there's an even more powerful feature that this screen has, and it's very subtle. See that little green tick up there? It's like maybe 64 pixels by 64 pixels. It's tiny, but it gives us some very important information. It's telling us whether the tip of this branch is currently passing the tests. And that little image has saved me days of development time over the last year. And I'll show you why. Imagine we're supposed to be using feature branching for our project. But then we have a developer turn up who's just a little bit too cool for school. And they decide that they're not going to create a branch to fix this problem in the authentication subsystem in Stash. So instead, she commits directly to master. And would you believe it? She breaks the tests. Now fortunately, she's smart, so she decides to commit again quickly and fix the tests. And the tests pass. Seeing that the tests are now passing, she thinks, okay, that's fine. I fixed it, I'm done, and disappears. Now you might think that this is okay, because we have a passing build, and we know that the next version of our product will effectively work. But there is one very important situation where this is going to cause somebody else a world of pain. Imagine we have another developer come in who's not too cool for school, and they create a branch. But they accidentally create a branch from that broken commit. Say this person is working on another subsystem, say the data access layer. They're going to make some changes, create the commit, and push it to the server. Now, although all of their tests are passing, they're going to see that same test failure that our other developer caused, and they're going to be really confused. Because although the test failure was caused by somebody else, they're going to think it's their fault. And as a developer, I'm going to make up all sorts of crazy scenarios as to how I could have caused that problem. I'm going to use my debugger, I'm going to step through the debug logs, I'm going to spend hours or days debugging what is somebody else's problem. And only eventually will I go back and look at the logs for master and find out that it's not my fault at all. And then I'm going to be very unhappy with that other developer. So that's why that little green tick, although it's so small, is very valuable for us as developers because it saves us this time that we spend debugging other people's problems. So that's a little bit about feature branching. I'm going to now show you one of the workflows that we use at Atlassian. Now this is the workflow that the Atlassian Marketplace team uses to develop marketplace.atlassian.com, which is a plugin exchange platform. So this is a good example of a SaaS workflow, because the only instance of Marketplace running is on a server that we control. So we can deploy updates to it whenever we like. And because of that, it means we can have a very simple workflow. Basically, we create branches off of master, get them feature complete, get the tests passing, and get them code reviewed, and then we merge them back into master when we're ready to release it. Now, this works most of the time, but there's one very subtle problem that can sometimes occur. Imagine if we change the shape of a REST API on the Jira 30 branch, and then you built a new feature that depends on the REST API in Jira 45. Though the tests will pass correctly on both branches, when they're merged together, those tests will fail. And that's going to mean that master will fail. And that's where we ship our releases to our customers, which is a bad thing. So what we've done on the Marketplace team is create a new branch that acts as a staging area for these changes. And what we do is we branch off this new branch, develop it, and merge back into that. And then once we're comfortable with the tests are passing and integrating correctly, we can merge that to master and deploy from there. So this gives us an extra level of stability for our branch. So that's an example of a SaaS workflow. Let's talk about an example of an installed product, Atlassian Stash. So this is actually the Git workflow that the Stash team uses to develop Stash. So Stash is an example of something that is deployed on servers all over the world. All of those customers on that list have their own version of Stash running behind their firewall, somewhere we can't touch. And we have a security policy at Atlassian where if we find a security bug in our software, for any version that was released in the last 12 months, then we'll patch that and re-release that version so that you don't have to do a major upgrade to get this new fix. Now, the fact that we have all of these stable release versions means that we have to have a slightly more complicated workflow, but it's still pretty straightforward. What we do is instead of just having a master branch, we actually create stable release branches. So here we have version 1.1 and version 1.2. Now, at this point in time, we've just created a branch for 1.2, which we're going to release in the next week. So what's happening here is we've decided to branch earlier, and then all of the hardening work that needs to be done to release the software gets done on that branch instead of master. So this has a nice effect where if developers want to work on the next version, say version 1.3, they can continue committing to master. And developers who still have outstanding work for 1.2 can continue committing to 1.2. Now, because we want all of the fixes in earlier versions to also be made to later versions, we have to, when we always branch off the earliest version that we want to fix, and then merge back into the branch that we want to fix. Then, because we want that fix in future versions, we merge from that branch into master. So this means that not only 1.2 gets the fix, but all future versions of Stash get it too. Now this is fine for a recent version, but say we found a bug in a much earlier version. We'd have to branch off that earlier version and then merge all the way forward. So for one bug fix, we have to do 3 merges. And this is kind of boring. And it's not only boring, it's a repetitive task. And just like issue keys, if you leave developers to do boring, repetitive tasks, they're going to screw it up. But if you mess this up, then you have a much bigger problem than messing up the issue key. If we forget to do this merge, then that means our bug fix stops on this branch. And that means that future versions of our code will have the same bug. So what we decided to do is to automate this process. So one of our developer advocates built a Git hook that will automatically merge bug fixes forward through your versions if you're following a semantic versioning scheme for your product. So semantic versioning is just 1.1 followed by 1.2 followed by 1.3, or a similar scheme to that. It just has to be able to be sorted numerically. And we like that feature so much, we decided to build it into Atlassian Stash. So per repository, you can turn on or off automatic forward merging for your release branches, which saves you a lot of time and saves you a lot of heartache when you accidentally fix and then unfix the same bug. So these are kind of different elements and a couple of examples of workflows that we use at Atlassian. Hopefully you can take these and use them to design a workflow that suits your product. So now I want to move on to a slightly different topic. I want to talk about improving code quality with Git. And it's kind of a trick because I'm actually talking about code review. And I use this picture because getting developers to do code review is a little bit like putting a baby in the bath. It's very good for the baby. It's very good for the people around the baby, but they might not be particularly happy about it the first couple of times. However, after a few times, you might find that developers start to enjoy code review. Can I get a show of hands for how many people are using code review where they work at the moment? Okay, cool. Not very many, maybe 15%? That's good. Hopefully I'll convince some of you by the end of this. So there are kind of 3 major reasons why I think code review is really important for developers. The first one is kind of obvious. It's that you end up with better code. And this is because different developers with different levels of experience and different specializations are going to be able to see different things about the code that you change. And this is kind of the most obvious reason to be doing code review. But sometimes that's the only thing that people think about. There's another very important reason, and this I like to call shared knowledge. When I first started at Atlassian, I was working on the Jira team, and they didn't do code review back then. But then I switched to the Fisheye and Crucible team. Crucible is a peer code review tool. So what this peer code review tool allowed me to do was see the changes that other developers were making to this product that I was working on. And I had 2 years of Java experience at the time, and I got to see the changes that people with 20 years of software development experience had made to this product. It also let me see the actual patterns that these developers were using on the product. So Crucible had a very specific type of database. It's called a B-tree database by a vendor called InfinityDB. Has anyone heard of InfinityDB before? No. And this is a very important point. I had never heard of InfinityDB before. So the only way I could learn about how to use InfinityDB was to read the documentation. So I asked for the documentation. There was no documentation. So the only way I had to learn about InfinityDB was by looking at the code. And I didn't want to read through 3 million lines of code, particularly when it had been written over a long period of time. So instead, I looked at some of the code reviews that people had created, making recent changes to this product. And that showed me the correct way to use it. So I not only learned more about Java, I learned about the specific patterns that good developers were using to maintain this product. So it saved me a whole bunch of time in learning the very things that I needed to know. There's a final, even more important reason to do code review. And this is a concept of team ownership of the code base. So I'd like to tell you a little story. Has anyone here ever shipped a bug to their customers? Come on, really? Honestly? Yeah. I've shipped many bugs, but I've fixed most of them. But it's a terrible experience. Shipping bugs is not funny, although it's fun to laugh. But you get this terrible sense of guilt and shame when you ship a bug, because it's all your fault. You made a change to the software, and then there's a customer on the other side of the world who's feeling a lot of pain because of something you built. In fact, I figured out the formula for this guilt. The guilt formula is G equals 1 over R plus 1, where R is the number of people who reviewed your code. So if you have 2 other people who reviewed your code, you only feel a third of the shame. So it's great. You do code review and suddenly bugs aren't your fault. Now that's not true. That's not why code review is important. There's another very important reason why this formula holds true. Imagine that someone wrote a bug in Atlassian Stash, and that person is in another country giving a presentation about Git to a bunch of really awesome, very attractive people. So then a bug gets discovered by the customers, but I'm not there to fix it. If we weren't doing code review, then one of my other team members would have to go and find out what that code is about and fix it themselves. And that might take them, several hours or maybe a couple of days, depending how complicated it was. But if we had 2 other people who were doing code review and looked at that change and gave the thumbs up, then not only are they equally culpable, so they're responsible for that bug, they're also going to be able to fix it very quickly because they know what that piece of software is about. So this concept of team ownership actually reduces the risk faced by your business. So that if the person who wrote the bug isn't present, there's going to be more people available to fix that bug. So that's all I'm going to say about code review. Hopefully those of you who aren't doing code review at the moment might start to consider it. But I'm going to talk about how you do code review in Git. So Git has this concept of a pull request. And what a pull request is basically a developer requesting that the rest of their team pull their changes into the master branch. And the most important part of a pull request is reviewing that change before you merge it. So in Stash, the pull request creation screen looks a little bit like this. It's basically a diff between the branch that you're merging in and the target branch. And it gives you a whole bunch of really useful information. It tells you whether the builds are passing, which is very important, because you want master to always be stable. You can also put it into diff mode to see all of the changes that you've made on that branch, which is very useful for me because I can be a little forgetful sometimes. So I can use the diff view to see if I've written tests, removed all of my logging, and basically have written a quality piece of code. So when you continue from that screen, you get taken onto this screen, where you have the title and the description of the pull request. And they are automatically generated for you, but you can change them if you have specific things you want to say. So the only thing you usually have to do is select some people to review your code. So usually you'll pick people who you think know about that particular piece of the code base. And I'll come back to that in a second. When you hit the create button, you start discussing your changes. So what that looks like is this. You have a diff viewer. Stash implements ediff, which means you can see the individual characters that have changed. And then we also have threaded comments, so you can have thorough conversations about the code that needs to be fixed. So if Jonathan had a problem with my code change, then he could chime in and say, we need to fix this. And then I can add some more code onto the branch, and the pull request will be automatically updated. So we continue iterating on the code until everyone's happy with it being merged. The other thing that we have in this view is a list of files on the left-hand side. So these are the files that changed on the branch. And we also track the state of whether you've read those files or not. So the bold ones are files we haven't reviewed yet, and the non-bold ones are files that we have. So if you have a very big review, you can make sure you can keep coming back to it and continue reviewing until you're ready. We also implement a side-by-side diff view. I usually use the unified diff view, but side-by-side can be useful if you have lots of little changes in the one file. And the other thing that Stash does that no other pull request implementation does is enforce certain invariants about your code. So you can say how many reviewers have to approve it before it can be merged. You can also say how many continuous integration builds have to pass before it can be merged. We also have a concept of pull request tasks. So if a reviewer has some things that they want you to do, they can create a list of checkboxes, and you have to go and check all of those boxes before you can merge a pull request. And what this means is that you can guarantee that the code being merged has been approved by all of the relevant people and meets all the conditions you have for shipping code to your customers. So that's pull requests. When you create a pull request, one of the questions you have to ask is who is the best person to review it? Now, this might be obvious if you work on a very small team, but if you work on a very large team, or if you are contributing to some code that you haven't worked with before, it can be hard to know who is the right domain expert, who actually knows about InfinityDB, or the authentication system, or the database. So Stash actually has a free add-on called the Auto-Suggest Reviewers plugin that analyzes the changes you've made and suggests some reviewers for you based on those changes. And it does this in a couple of different ways. The first thing it does is it looks for other authors on the same branch and suggests that they would be good people to review the code because they contributed some of the code for that feature. The second algorithm that it implements is a little bit more clever. It actually goes back in time and runs git blame on the files that change the most on that branch. It then analyzes the output from that blame command and determines who contributed the most to each of those files. Then it looks at the lines that you added to that file and then suggests that you add other people who previously contributed to those files as reviewers. And this algorithm is pretty much what I do as a developer when I'm thinking about reviewer selection. I add people who have previously worked on these files. But in Stash, we do that automatically for you. But these are just suggestions, so you can still choose who you want to review your code at the end of the day. So I'm going to move off code review now and talk about how Git integrates with the tools that you're using at your organization. First of all, I want to talk about Git and continuous integration. Is anyone here using continuous integration for testing their code? Maybe Bamboo or Jenkins or Hudson? Nope. Okay, cool. So maybe about 30% of the audience are using continuous integration. So I want to show you a little comic from a site called XKCD. what's happening here is two developers are sword fighting in the kitchen. The reason they're sword fighting is because they're bored. And they're bored because their code is currently compiling. Because while your code is compiling, your computer's resources are all very busy, and you can't do anything with your development machine. So you go and sword fight. Now, this comic was written about 5 or 6 years ago. In 2014, computers are very fast. CPUs are much quicker. You can have more CPUs on the same board, and the amount of RAM you can have is not only faster, but it's way through the roof. So compiling code is no longer a problem, and not an excuse to sword fight. But there is one other thing that takes a lot of time, and that is running the tests. So the stash functional tests, if you run them all at the same time, take about 28 hours to complete. So what we've done is we've batched all of those tests into a series of builds that run concurrently. But even all of these series of builds running at the same time still takes 40 minutes to complete, which is plenty of time for a sword fight. So what we want to do is save developers that time. So the common wisdom with continuous integration is to always build your master branch to make sure that the code that you're shipping to your customers is passing the tests. That makes sense. What you can do with Git is also build your feature branches. So what this means is that you can guarantee that your tests are passing before you merge it back to master. Now what's really nice about Bamboo is you can actually automatically detect when a developer pushes the branch to the server. So as a developer, if I want to run the tests, I don't run them on my computer anymore. Instead, I push my branch to the server. And then Atlassian Bamboo detects that the branch has been created and builds it for me. So this is very convenient because I don't have time to sword fight. Instead, I start working on another feature, which means I'm more productive as a developer, and I can develop features in parallel. Now, the only problem with this is that we're going to be building the software every time a developer pushes. At Atlassian, we run about 400,000 builds per month. That's a lot of builds and a lot of hardware that has to run those builds. Now, with things like the electronic compute cloud from Amazon and other scalable infrastructure, that is, it's a possibility, particularly if you have other data centers as well. But it can be expensive for some organizations. So you can also configure Bamboo to create new plans for you when you push it, but then a developer goes in and actually manually runs the test in the cloud. So this means that you can only run the tests just before you merge to make sure that everything's okay. Hopefully, once you switch to feature branching, you can implement one of these strategies. I still think that this one is the nicest for developers, and to be honest, developers probably cost more than computers. So if you're saving developer time, I highly recommend this bottom one. But if scaling up your build infrastructure is a bit of a problem in the short term, then you can always go with the second option. Regardless, it will save your developers time and make them much more productive. So now I want to talk about issue tracking with Git. Because all of our branches have issue keys relating the code changes to the issue, we can now link our Jira issue to a whole wealth of information. From Jira Agile, we can see the sprints. From Bamboo, we can see our builds. From Stash, we can see our branches and our pull requests. And all of this is displayed in our Jira issue. So this means that a team lead can quickly see the state of an issue, not only in Jira, but how it's actually implemented in the repository. And this is very valuable because to find this information out would otherwise mean going to every single tool and searching for these issue keys. But this is much more convenient. Now, while this is useful, we've actually made it even more useful in Jira 6.3.3. Now, we've actually built a feature where Jira will change your issues when you change your code. Now, this is a little bit ironic because it's a Jira feature that actually makes me use Jira less. As a developer, I now go to Jira to assign myself an issue. That when an issue is originally assigned, it's usually in the open state. But then I leave Jira and I never go back. Because when I create a branch, Jira will put that issue in progress for me because it detects that the branch has been created. And when I create a pull request back into master, Jira detects that and transitions it into in review. And when I merge that pull request, Jira transitions the issue into done. Which means that I, as a developer, don't have to use Jira anymore, at least not after I assign the issue to myself. So again, this is just a very convenient way for me to interact with my tools and spend more time doing development and less time doing tracking. If you're familiar with Jira, this is what the trigger screen looks like. So Jira has a very flexible workflow system, and you can now bind triggers to any workflow state or transition. Is anyone here using Jira for issue tracking? Okay, cool. Maybe a few people, 30%. So basically, this is a really flexible way to customize your Jira workflow from scratch. The last tool that I want to talk about is Atlassian HipChat. We've actually recently made HipChat free for its basic usage, which means you can chat with the rest of your team and integrate tools with it. So the reason I like HipChat as a developer is I now have a different room for each project that I'm working on. And this is very important for my workflow. I live in San Francisco these days, but I used to live in Australia. When I lived in Australia, I was working very closely with one team, all in the same place. In San Francisco, I work with one other developer, but I also work with 8 other developers in Sydney. So there's a big time zone difference. We only have about 1 hour of overlap in the afternoon. It's about the same as Tokyo to San Francisco. Now, this used to be a big problem for us, particularly when we collaborated over email. But with HipChat, when I get into work in the morning, I can just scroll back up and see all of the things that have happened overnight. I can see which bugs have been created and fixed. I can see which builds are passing and failing. And I can see which pull requests need to be reviewed by people on my team. So instead of having to write big status emails, I can just look at my HipChat history and do what is ever most important for my team. So we've talked about a collection of tools. We've also talked about a whole bunch of reasons why Git is very powerful for software developers. It gives you more time to do development and less time spent organizing. It allows for better collaboration, even across time zones in other parts of the world. And it makes individual developers much more productive because of all of those great, powerful commands that Abhin showed. And we also firmly believe that Git is the future of software development. When you look at the amount of teams using Git out there, it's about 50% of development teams, with 50% still on other version control systems like the Force or Subversion, or even CVS. But that number has rapidly changed from 2010. We're about 100% up from 2010 to 2014. And looking at all of those companies that are using Git and Stash for development, we believe that almost every team will be using Git in the coming years. But if you're not using Git, these aren't the things that I want you to remember. What I want you to remember is the simple economic argument for Git. Git lets you ship software faster. It also lets you ship software with higher quality, which means less bugs and happier customers. Happier customers are hopefully going to buy more of your software. And this is why Git helps you ship software faster and smarter. Thank you very much for listening.
Thank you, team. Abhin、ご清聴いただきありがとうございました。また、先ほどは大変失礼しました。質疑応答に移りたいと思います。質問のある方は再び挙手をお願いいたします。向かって右側の、はい、ボーダーの方お願いいたします。
Hey, thanks for the talk. This might be a bit too deep in like the internals, so you might not know, but you were talking about the speed of Git and how amazing it is because it was written by Torvalds and stuff. But like 2 years ago or so, at my previous company, we had real problems with several commands, like for instance blame, because first of all, there's like no secondary cache in Git between the file or the path and the hash. So what blame does, it has to check all the commits and check all the stuff, and that's kind of slow with I/O. Talking about I/O, like Git at least used to use lstat for it. So if your inode or dentry caches are not warm or you get many hits, that's also bad for your I/O. And the best part was that the Git index, like the index that Git cache that it uses, it could get really huge, like 100 megabytes up, and whenever one entry got invalidated, it would invalidate the whole thing, and etc. Anyway, so do you know that those kind of stuff got fixed or not? Because for me that was like a no-go for me.
Absolutely. So, that's weird. Sorry, I can hear myself talk. Yes, so there's a few different questions there. The large index problem with Git has been experimentally fixed in Git 2.1. They actually built a new feature where it creates an additional file, or in fact an additional set of files, rather than rewriting the original index. So it doesn't have to rewrite a huge 100 megabyte file if you have a very large change that you're staging. As to the other performance issues, I must admit I'm not sure if they're still using lstat or not. I do know that pretty much every major and minor release of Git does come with a set of performance improvements. And Scott Chacon, one of the Git core contributors, seems to regularly be updating and thinking about how to improve it. So if it's not solved yet, I imagine that they are continually thinking about it. I'm just curious, what version control system did you end up going with?
Oh, yeah, we're going with Git, but it's, it's like the lesser of two evils.
Gotcha, yeah.
I actually am interested R&D working on something your own, like something not language agnostic, something, because that's the biggest problem for me with Git. It's like language agnostic, so I get a lot of small, stupid conflicts that could actually be, resolved by the version control system if it knew that I'm writing in Java or JavaScript or whatever.
Gotcha. Yeah, so that is another problem with any version control system, that you can end up with conflicts. What Git does allow you, have you played with custom merge drivers?
Yes.
Okay, yeah, so for those who haven't used it, Git has a concept called a merge driver, where you can instruct Git to merge certain files in certain ways. But I don't know, and there are, if you Google for Java merge drivers, there are some common ones for merging .xml files from Abhin, but yes, I agree. There are other Git merge algorithms as well. Like the patience merge algorithm sometimes has a better effect, but it can take a long time.
Okay, thanks.
Yeah. I guess the takeaway there is that yes, there are, like every version control system has some drawbacks. Git is the fastest thing out there, but it can still be faster. And there are a large team of contributors working on performance improvements for Git. It's just a matter of time. At the end of the day, Git is open source. So if you are feeling pain from a particular feature in Git, then you can always go and make those improvements yourself. Are there any other questions?
一番前の白石の方お願いいたします。
Thank you for your presentation. As you know, Atlassian has two Git products, Bitbucket and such. And so I want to know about future plan of those products. And those products have a little bit different functionality. So Bitbucket has some good function, but there is no similar function on the Slash. And so I feel always please implement it into the Slash. And at least I'd like you to implement some main functionality. So I want to know about the future plan of those products. And they will go different paths or different way.
So with Bitbucket and Stash, originally Bitbucket was developed just in San Francisco, and Stash was developed in Sydney. But we now have a common core group developing both. So while individual developers work on Bitbucket or Stash, they now report to the same product manager. So we're aiming to have consistency between both products. So we do want to try and roll out features to both of them at the same time. They're actually implemented completely separately. Bitbucket, so Abhin is a Python developer working on Bitbucket, and I'm a Java developer working on Stash. But we do use a lot of the same patterns and a lot of the same user interface stuff, so common HTML and CSS and JavaScript. And we do try and make them we are working on making them as consistent as possible. So yes, absolutely, we are working on that.
Thank you very much.
No worries.
ありがとうございます。続いて向かって左側の2列目の方お願いいたします。
すみません、日本語で。ゲーム会社なんですけれども、今弊社でパワーフォースを使っていて、開発者の方はみんな Git を使いたいけど、アーティストの方は、Git とかわからないから使えないということで、結局パワーフォースでもやってます。あとアセット 3D のデータとかが大量にあるので、どうしてもローカルに全部置けないっていうような理由から Git を見送ってるっていうのがあるんですけれども、そういったところでソリューションで何かいいアイデアとかもしあれば、ぜひ教えていただきたいなと思いますが。
Absolutely. That's quite a common problem with teams trying to move to Git. The way that Git initially stores binary files in the repository is to take a snapshot of the whole file and then store it in a place called the Git objects directory. If you change that large binary file, then it takes another snapshot and stores the whole thing in that objects directory. It doesn't store a delta. It does eventually pack those things into deltas, but at least initially those files can be very big. So Git natively doesn't handle, well, it does handle big files, but you can run into problems, particularly in the gaming industry, where you have lots of 3D assets or large images. Even with Java, if you're storing dependencies in Git, like jar files, you can run into problems. Fortunately, there are some Git projects that solve this problem. There's one called Git Annex, another one called Git Fat, another one called Git Media, which is maintained by Scotchicon. Each of these store these large objects in a separate, special type of remote. So you might take a look at those and give it a try. There are some other Git features that you can use, including a shadow clone, where all of your objects are stored on the server, but you just pull down the most recent version instead of the full history. Now this isn't ideal because you can't do merges that involve a common ancestor from before that time, but it can sometimes help. You can also use commands like git filter branch to rewrite your history to remove some of these assets, but that doesn't necessarily help if you're working with large assets anyway. I'd recommend checking out git annex, git fat, or git media.
Thank you very much.
質問ありがとうございました。時間もしていますので、時間もしていますので、質問に関してはこれで終了にさせていただきたいと思います。この後のネットワーキングパーティーでティム、アービーも参加しますので、ご質問がある方はそちらで個別にご質問をお願いいたします。ティム、アービー、thank you。それでは続いての